I know you normally like to do your own demos, but I heard that today you have brought someone else to take a look at Kubeflow.
Been eclipsed in the demo department by real professionals and people who own their stuff and love their stuff. So I can't wait to see them at it.
All right, I think Rui is coming to join us right now. Mark, thank you very much. We will see you later today.
Looking forward to it. To all of you folks who've joined us for the day, this is going to be a great start to a great week. For the software engineering heads, the deep dive in how to build sidecar operators with the charmed operators with the Python operator framework is going to be really interesting. For me, it's really important to open up to a new kind of a base of contributors in the operations world, right? The Kubernetes world is really quite deep and software developer oriented, but the operations world needs a much broader base of skills. So I think that's an important thing that hopefully you'll get a taste of later today. I'd love it if you would stick around or come back for the sort of manifesto conversation with Ken Sipes, where we're really going to look at the state of the art and have a kind of a conversation that goes beyond vendors to sort of say, okay, what does the world really need from an operator point of view? With operators, everyone's excited about operators now, but what are the key values that will make this usable and consumable over the next couple of years? So that's going to be a great conversation. I'll leave you guys to it and catch you later.
Thanks a lot, Mark.
Thank you.
Rui, take it
All
away.
right. Hi, everyone. My name is Rui. I'm a product manager for Kubeflow. And Kubeflow is a bundle of about 20 applications. Now, even if you're not in the ML space, you probably have an application that is made of a bunch of other applications. So this part is also relevant to you. I'm going to deploy and integrate all 20 of the Kubeflow applications with a little code that I can launch in about 2 minutes. So if you are very familiar with the latest on Kubeflow, you will understand what's going on behind the scenes. But if you don't, do not worry about it at this point. I will tell you why this is cool in just a minute. So let's start coding. So I've prepared basic Ubuntu 2004 instance where I installed just a couple of snaps. I've installed Juju Snap version 2.9 and MicroK8 version 1.20.06. And I've also enabled a few services, which we can see with the MicroK8 status command. So you can see that I have enabled DNS, MetalLB, and storage, which are basic things that will be useful for this demo. This is MicroK8, but in fact, we look at it as a normal Kubernetes cluster, and by that I mean that we can access it via kubectl, and we can see all the pods that are running at this moment. Again, nothing special. MetalLB, a few basic things like core DNS and so on, and we have a kubeconfig file in the default path, which allows us later on, allows Juju to actually find our Kubernetes cluster. If we look at this through a Juju perspective, with Juju status, and this terminal is dead for some reason. Let's go to close it and open a new window, and SSH. Okay. So if we do Juju status here, we see that no controllers are registered. This means that Juju doesn't know about any cloud at this point or any Kubernetes cluster. So we have to start by letting Juju know that we do have a Kubernetes cluster. And we could do this with the Juju add k8s command and give a name to our Kubernetes cluster. We can call it myk8s. Let's go and do that. And it tells us that in order to then control this Kubernetes cluster with Juju, we have to create a controller that we can do with the bootstrap command. So let's go ahead and bootstrap our myk8s cluster, and we can call our controller something like mycontrol. So effectively, what we are doing here is that we are launching a couple of controller pods in our Kubernetes cluster that will allow Juju effectively act on that cluster to deploy the applications that we want to deploy to that cluster and monitor them, so that we have effectively control over our cluster via Juju. So this should be done very briefly, and we can see as soon as this is done that a couple of these controller pods were created. Okay, so if we go and look at all the pods in all namespaces again, we see that, and we can do that once again, we see that a couple of pods were created here, model operator and controller under the controller my controller namespace. So that's basically what we did so far. And we can see that from a Juju perspective, Juju tells us that, okay, now to deploy workloads on top of your Kubernetes cluster, you need to create a model with the Juju add model command. And you can think of a model as a blank canvas, as Mark and David were discussing, blank canvas where you can deploy applications that are interconnected somehow, and you can integrate them. So let's go ahead and create a model, and let's call it Kubeflow. So that was quick. And we can see that if we get now the namespaces, the Kubeflow namespace was created also 9 seconds ago. So we effectively, by creating a Juju model, we created the Kubeflow or Kubernetes namespace with the same name. So why did we do all this? We did all this so that we could effectively deploy Kubeflow, or our set of a lot of applications that are interconnected, with one command. We can go ahead and Juju deploy Kubeflow. And let's go ahead and do that. And we can watch what's happening, which is this pre-package group of integrated applications. And we see that all of these things are being resolved. And we can watch what's going on in this process via a Kubernetes view. So we can get all pods from Kubeflow namespace and watch as they kind of get spun up. And we see that all of these charmed operators were located and things were resolved. And we can also watch what's going on from a Juju status perspective. So we see that there's a lot of things going on here. List of applications that appear to be in a waiting status. And effectively, we can see that there's a bunch of applications here being deployed and that are now in a waiting status. And we will be able to see that they start popping up here in our Kubernetes, that a bunch of pods will start to get deployed. And we see here also things will go from waiting to maintenance to active status, and effectively this dynamically will be deployed. So let's give it a few minutes to actually get deployed. And in the meantime, let's go back to the deck. So let's take a step back. MLOps, like many other domains, at scale is painfully complex. And we know, otherwise we wouldn't be at KubeCon, we know that large-scale compute is moving to Kubernetes. For those of you not familiar with Kubeflow, simplistically, it maps machine learning workflow steps into Kubernetes jobs. And charmed operators manage installation, configuration, integration, and upgrades for your software stacks like Kubeflow. So this is the main concept. Let's look again at the deployment to see if nothing surprising appeared here. It seemed that well, a few more applications were deployed. It's still resolving a bunch of stuff. So let's give it a few more minutes. And in the meantime, I will actually explain step by step what I did here in a more visual way, so that you can fully understand what we did. So we started with a Kubernetes cluster. We started with microcrates, but we could have done this with EKS or GKE or any other Kubernetes cluster, provided that we have access to it via kubectl, and that we have a kubeconfig file in some location. If we have it in the default location, then Juju knows how to look for it right away. If not, we can specify the right location where we have that file. And we've installed we had installed the Juju client already. So we had to let Juju know about our Kubernetes cluster. And we did that with the Juju add k8s command, and we gave it a name to our Kubernetes cluster. Then next, in order for us to actually manage applications in our Kubernetes cluster, we created a controller with the Juju bootstrap command and named it mycontrol. And finally, we created this blank canvas where we could deploy our Kubeflow applications, and we named it the Kubeflow model. And all of this allowed us to drop a bunch of applications into a substrate at the same time. So pretty cool, right? Let's go and look again at the deployment. Okay, still deploying, but we can see that every time we look, there's a few more things. And this is the reality, right? Like there's a lot of things to be deployed and integrated, and that's why it's complex. So what we effectively need is a bunch of integrated applications that just work in the substrate that we need them. So why is this cool? Now, Kubeflow 1.3 just released. Yay! It was a great effort by the community. But that also means that everybody, everywhere, will have to tear down their old version and deploy the new customized manifests. And every time one of the 20 applications decides to release, you got to do it all again. So now imagine when you have Kubeflow integrated with a feature store, with MLflow model registry, with 2 streaming and 1 batch infra system, Pachyderm for data versioning, and 37 data stores and data sources. Without charmed operators, you need to be a Kubernetes and Kubeflow expert and spend your weekends on it just to handle the upgrade cycle. Charmed operators take a lot of that work off of your hands and share it with the community of experts. Dan Jeffries, who is here with us today, leads such a community. And I would like to welcome him here now to talk a little bit about the issues that his community is facing in this regard. Welcome, Dan. Thank you for joining us.
Thanks for having me. Appreciate it. I mean, it's amazing to watch you kind of deploy some incredibly complicated stuff on the back end, right? And you know, I'd say in our community, so we definitely want to simplify a lot of these deployments, right? So I'm the managing director of the Artificial Intelligence Infrastructure Alliance, which is pronounced AIA for short. And I'm also the chief technical evangelist for Pachyderm, which is a data version and data lineage engine for machine learning. And at the AIA, we brought together basically 40 of most cutting edge companies and communities in artificial intelligence and machine learning. And we're proud to have Canonical as one of those partners. And together we're working to build all of those components. So we want a robust end-to-end machine learning workflow, you know, whether that's best of breed pipelines or labeling engines, data versioning, feature stores, experiment trackers, model serving, monitoring, and more. You know, we're outlining the blueprint for multiple stacks that can take on everything from reinforcement learning to structured data and unstructured data, and allows folks to focus on AI instead of IT. And you see how complex some of these things are. So we definitely want to reduce the sheer amount of applications that are being done. But no matter what we do, you're going to have a lot of different Lego bricks within this complex ecosystem, and it's continuing to evolve. We have a Cambridge explosion of wonderful technology and artificial intelligence. That's going to go on for a number of years. So really one of the most essential parts of our mission is to create a smooth interoperability between the products and the projects to help deliver that ML workflow from start to finish. And today there really is no end-to-end platform. Don't believe the marketing hype. It's just a lot of disjointed individual parts. And that's why we're coming together to try to create clean endpoints, APIs, orchestration, so the parts can start to work together seamlessly. And like a lot of the people in this space, the alliance, a bunch of the alliance members are using Kubernetes and containers to address that scale and load, which you folks are dealing with beautifully here today, and helping kind of reduce the complexity in that kind of wonderful space. But of course, again, our space is really evolving quickly. Many people are kind of working on the same problem in silos, and we don't want to be in a place where people are doing deployment and integration and operations, and that takes more time than actually using the tools to solve machine learning problems. We want our engineers solving those machine learning problems. We want them moving up the stack. So why should every team have to really deploy or rewrite the same glue code across their organization or across other organizations? So yeah, we're very excited to be here on Operator Day with our partners Canonical, and we feel that the Charmed Operator Framework can help us solve a number of these integration challenges, letting us bring together the deployment and communications at different layers in the stack. And we want to help all the AI engineering teams out there find and build the best stacks to solve the biggest challenges in machine learning, so they can focus on the AI and not the IT.
Thank you so much, Dan, for sharing all of those exciting work that you guys have been doing. So in short, whether you're in the ML space or have an interconnected application, Charmed operators help you to move from configuration management to application management. So let's build one now. Actually, I would like to introduce you, John, who is going to guide us on how to build an operator charm and really dive into the details so that we can all make this vision reality. Welcome, John. Thank you.